So the decision for dividing the network into subnets, depending on many factors, of course, we need to plan carefully the maximum number of hosts per subnet, and also the structure of the building or the organization, like in the case of Qatar University, dictates the number of labs and the number of typical subnets that we need inside our network. So depending on that, we can determine the number of bits that we need to borrow for subnet, or the number of bits that we need to maintain for representing the hosts per subnet. So this example here, this animation shows the fact that if we have 8 bits, so we can have up to 254 different hosts per subnet, and in that case, we have only one network. So if we borrow one extra bit, so this will give us 7 bits for hosts, and in that case, we can represent 126 for 2 subnets. If we want to have 4 subnets, we end up with 64 different hosts per subnet. If we need 8 subnets, we can represent 32. If we have 16 subnets, we end up with 14, and so on. One thing to notice here is that the more subnets you divide the network to, the more addresses you lose here, because in each subnet, you need to maintain 2 special addresses for subnet address and broadcast address. So for each subnet, you lose 2 addresses. So it's also not advisable to divide the network into many subnets. In planning the subnets, you need to take into consideration the structure of the organization or the building or the corporate network. So if you have different departments, this also is a factor in determining the typical number of subnets, and in that case, it dictates the number of bits that you need to borrow from the host portion of the address. And always the number of subnets is 2 to the power n, whereas n is the number of borrowed bits from the host portion. So this structure here shows the number of departments in a certain organization, and the requirement in terms of the number of hosts per department. So the Department of Engineering, it requires 190 hosts. The Department of Human Resources requires 170 hosts, and so on. Another factor that you need to keep into consideration is the growth of the number of hosts for the future. So not only do you have to plan for the maximum number of hosts per department, and in that case it's 270, so this is the maximum number of hosts per subnet, but you need to also think about the future growth. So you may need to have a certain factor where you can increase this number of hosts per subnet to accommodate the future growth. So in that case, this will dictate the number of bits that you need to maintain for the host portion and the number of bits that you need to borrow from that host portion to represent the different subnets. So this example here shows how to determine the number of subnets and the size of each network. So if we have a network with this network part, and the host portion is, in that case, it's 10 bits. And in that case, this network address is 172.16.0.0/22. So for this network address, we have 10 bits for host, and this will give us 1,022 different hosts, which is 2 to the power 10 minus 2. So imagine if we want to divide this into 16 different subnets, so we need to borrow another 4 bits, and this will have the subnet prefix as /26, and we have 4 bits here to represent the subnet number. So starting from 0000 all the way to 1111 here. And in that case, we end up with only 6 bits for the host portion. And in that case, the number of valid host addresses that we can have is 62, which is 2 to the power 6 minus 2. So this example here shows how to design the subnetwork address based on the number of hosts needed per subnet. So the first example here shows you that we have 250 hosts required, and in that case we need 8 bits for hosts and 24 for the network. So the subnet mask is 24 ones and the rest will be zeros, and this is slash 24. If the number of hosts required is 25, remember that if we have 4 bits per host, this will give us 16 minus 2, which is 14. So we need another bit. So we need 5 different bits for hosts. So the subnetwork mask in that case will be 8 ones, 8 ones, 8 ones, and then we need 5 bits, so this will give us 1, 1, 1, and then the rest will be zeros. Okay, so this is actually in decimal 255.255.224, because as we said, 2 ones and all zeros is 192, so 111 and the rest is zeros is 224. And this will be, of course, slash 24 plus 3 is slash 27. Okay, so 1000 will require 10 bits to have 1024. So this will require that we have to borrow all the 8 bits here and 2 other from the third byte. So this will give us 8 ones, and then 8 ones, and then here we need 6 ones, and then 0, 0, and the rest will be zeros. So this is actually 255 dot, this will be 252.0. This is slash 22. Okay, so the next one, 55. Remember that 64 is 6 bits, so we need 7 bits to give us 128. Because if we have only 6 bits, this will give us only 64. So we need another 7th bit from the last byte to represent the 75 different host addresses. So we have here 8 ones, and then 8 ones, and then 8 ones, and then here we need only 1, and then the rest will be zeros. And of course, this is 255, 128. And of course, 24 plus 1, this is 25. All right. So the next, 10, of course, if we have 3 bits, this will give us 8. So we need 4 bits to give us 16. So 4 bits, so 8 ones, 8 ones, 8 ones. And then here we need 4 bits, so 1, 1, 1, 1, and the rest will be 0, 0, 0, 0. Okay, and of course this is 255, 255, 255 dot. So this is 128, 192, 224, and this is 240. And this will be, of course, 24 plus 4. This is 28. All right, 500. Of course. 8 bits will give us 256, so we need 512. So we need to borrow another bit from the third byte, so this will give us 8 ones, 8 ones, and then here we need 7 ones, and then 0, and then the rest will be zeros. Okay, so of course this is 255 dot, of course, the third byte will be 255 minus 1, which is 254. And this, of course, will be slash 23. I really hope this is correct. There is so many numbers and calculations here. So let's see. Okay. So let's see what's wrong here. Oh, here. Okay. So this will be 0. Sorry. All right. So 254. Okay. Let's see. Right. Okay.